Hello, Keegan. Yeah, so let's dive into the first presentation about natural selection and man-made selection on honeybees today. I'll try to make it as brief as possible and give you, just focused information. If there are any questions afterwards, just approach me or tell me these, and I'll come online, or we can talk about it, or I will just write you the answers. Anyhow, let's dive into the topic and see that we get through. Okay, man-made breeding and selection is the honeybee's demise. That was a presentation that I gave to the London Beekeepers Association, and they thought it was really thought-provoking. Yeah, let's take a look into evolution natural selection. As you know, a parental generation generates an abundance of offspring naturally, and then the offspring differs in phenotype, in the look and genotype, and the behavior due to the recombination and mutation of the genes. And especially when it comes to bees, because a queen is going to mate with like 20 different drones, and she's saving all the sperms that she is receiving in these mating processes during her whole lifetime. So she has a huge diversity of genetic information within her body. And so she's the only mother of the beehive or the bee colony, but all the brothers and sisters in the bee colony, they have like 20 different fathers. So the variety of different genes is huge. And that's why they can adapt to or change their behavior, and they have a variety of behaviors. Yeah, that is being played out when it comes to adaptation or changing conditions. Yeah, so natural selection kills all offspring that is not showing the behaviors that are needed to survive in a certain location. And for thousands of years, humans did not interfere even in beekeeping with these principles, because skeps and lock hives provided almost natural conditions, and the beekeepers didn't interfere with the reproduction with swarming or mating and survival of the fittest. That's totally changed today, and there was no massive manipulation like adding space, hindering swarms, feeding, and so on. So we didn't interfere with a natural hierarchy of behavior that honeybees show when they are living in natural conditions, which is a very important point. So many of the colonies that we have in boxes do not show natural behavior because they are living in boxes, and they have to compensate what we put on them. But they were, when it comes to the genes, many of them are able or capable of showing these natural behaviors, which we don't know. We just simply don't know, because they are not being played out because of the fact that we are operating the bee colony or breaking the natural behaviors. So no massive manipulation like adding space, hindering swarms, feeding, and so on was being made for thousands of years. That changed after the Second World War, when we started industrial sugar production. So survival of the species is always based on the oscillating level of offspring and death rate, so selection. And I always say that a parental generation creates a mass of offspring, and then natural selection kicks in and creates a locally adapted class out of the mass. So you have always the oscillation of an abundance of offspring, and then natural selection is going to decrease these numbers to the normal density. Only the colonies who were adapted to natural demands and local conditions will survive and pass on their new genes. That's totally different even today in beekeeping, because here in Germany, a lot of queens that are being bred in Spain are being sent in packages to Germany, and the German beekeepers will kill the queens by squeezing them to death. And then they introduce new queens bred in Spain by a beekeeper with a one drone insemination. So no more 20 drones that are mating with a queen, but one drone is being squeezed out, the sperm is being taken, and then they inject it into the queen. So there is the huge diversity is gone with with a natural that we see in natural mating, and that's why when they do this, they can very effectively determine the bee's behavior that they want to, which is serving our needs, but which is horrific to the bees themselves because it robs them a huge diversity of behaviors that they would need. So there's an example in the Arnott Forest. Tom Seeley has done research in the Arnott Forest, as you might know from his books, and he has done scientific research on the bee colonies there, the density of one hive per square kilometer throughout 40 years, that he could show that the density was not higher than one bee colony in a square kilometer in that forest. So, and there was an interesting aspect because the varroa mites, the parasite which origins in Asia, arrived in the Arnott Forest, I think it was 1995. And Tom Seeley has taken genetic samples of the bees living in the Arnott Forest before. And after a few years, he thought, well, because of the fact that all the colonies in the boxes in the beekeeping apiaries, they kind of collapse with the varroa mites coming or arriving there. And so he thought, okay, I'll go back into the Arnott Forest and see how the bees are doing there. And he was surprised because he could find the density of one bee colony per square kilometer, that nothing had changed basically. So he caught like a lot of swarms with swarm trap in that forest, and then he did his research and he could find that every swarm had varroa mites. So the varroa mites, they of course had arrived in the Arnott Forest, but the bees didn't seem to have a problem with this. However, when he did scientific research on the genes, he could see that before the arrival of the varroa mites in the Arnott Forest, there were like 20 plus genetic lines, and afterwards there was just a handful of genetic lines. So he could prove that with the arrival of the varroa mite in the Arnott Forest, the honeybee colonies were going through a bottleneck of selection, and many of these genetic lines failed, so they died. But because of the fact that a parental generation generates more offspring than it is needed to make the species survive, the survivors had then created more offspring, or the offspring of the survivors were able to occupy the then empty tree cavities. And so nature has adapted to the varroa mite problem within a few years, which is a good example, because we are keeping that problem alive now since 1977 here in Germany, when the varroa mite arrived here in Germany in 77. And by treating the bees with chemistry, so we are not allowing any adaptation, and furthermore, of course, we are using beekeeping techniques that are increasing the amount of deadly varroa mites significantly. So it's more the fact that we are of our beekeeping techniques, which is hindering the bees to go after the varroa mites, which we will see later on. And of course, there is no natural selection anymore, which is a shame. Okay, so when it comes to natural selectional processes, we have multiple selectional processes when it comes to bees. The first one is the queen. So when a bee colony is ready in the early summertime to swarm, then the colony or the worker bees will create a little bit bigger cells. And if the queen feels, okay, now it's time to swarm, then she will breed these cells. She will put an egg into it. And we don't know which egg is being chosen to become a new queen. It might be a choice of the queen, which we don't know. So we don't know which queen will be the first to hatch, and why it is the first to hatch. Is it the temperature, the humidity, the place in the colony? Is it the genetics? So there are a lot of open questions. And then normally there will be like 15 new queen cells in one colony, and we don't know how the colony takes its choice. and how they know collectively which queens need to be killed or if they need to be killed. So if there are a lot of bees in the hive, then even the old queen will accept the new queens, and they will be kind of not fighting each other if the weather is bad for a few days, until it's, you know, they are able to swarm, and then the bees of course will swarm. And sometimes you have one or two queens in the new swarm, and then they will choose, you know, the bees will choose collectively with which queen they will go, but we don't know how these selection processes are being made by the bees. Otherwise, I've seen in a hive that worker bees were going after the abundance of queens. So then you had like 8 or 9 queens too much or too many, and then they were, yeah, they are going after them and killing them. And of course I raised the question, how do they know which queen needs to be killed? I mean, collectively there are like hundreds of bees chasing after these queens, and they need to kind of yeah, they need to have a solution which one they want to keep and which one they want to kill. And we don't know anything of these selection processes, and we don't know how they decide whether they accept an abundance of queens, how much swarms they are going to create, or how much queens they are going to kill, and which queens are going to be killed. So we don't know anything of that, but we feel that we can do it better by human selection, which is absurd. So the second selection are the drones, the mating places of the queens, and so the virgin queens and the drones are usually miles away from the colony, and they meet in certain locations. I've seen some research. It says there's a kind of you know, it's the structure of the ground that they know that they are going to meet there, but we don't know how the queens and the drones know where to meet. But we know that there are some places where they do meet in the air, and then the mating happens in the air. So only the most vital queens and drones will be getting there and compete with each other within the flight of mating with a queen. And so only the best genes will be transferred. Okay, so in man-made breeding, we squeeze out one drone out of a hive that we feel, okay, that's really calm, it's creating a lot of honey. So we squeeze this drone out, take that semen, and inject it into the queen. So we do one drone insemination, and trying to get the same queen again, or the same, you know, a colony with the same features that is subdued to our personal needs, which is calm, which is creating a lot of honey, and so on and so forth. We will look into that later. So in nature, that's totally different. This causes a rich diversity of behavior and abilities. It's called faceting. So you have a lot of facets of behavior based on the fact that you have like 20 different packages of semen from 20 different drones, and these were the drones that were able to get miles away into the air and were competing with all the other air acrobats for the mating. So it's a very hard selection process. The various different behaviors and abilities are based on the genetics when it comes to bees. So bees cannot really learn anything. Of course, they can, they can communicate and so on and so forth, but all the behavior that bees have is based in the genes. So moreover, there's a hierarchy of behavior, and it's a huge composition of different behaviors and its hierarchy that must be right in order to survive without any human interference. And so I might give you an example. All the worker bees can sting. Doesn't mean that they are flying genetically, they can sting. Doesn't mean that they are flying around and stinging all living creatures all day long. It doesn't make any sense. So of course you need a certain trigger of that behavior, and you need the right amount of that behavior that's being played out and the right time of the behavior, or the time phase of the behavior that is needed to be shown in order to be effective. So it's not only the genetic information that a bee can sting, it needs to have its triggers, and it needs to have the right composition of how much of that behavior is being shown, how long it is being shown, how intense it is being played out. And this is then just bear with me. Deciding whether a bee colony has the right composition. So it's not only simply the genetic information. As an example, if a bee colony sets up too much brood in a set volume, so if you have a bee colony that is swarming out of a hive, and which is really huge, and then is occupying a tree cavity, which has a set volume, it's much smaller. So if they then create too much brood, which is a breeding goal in beekeeping, that you have colonies that are creating a lot of brood, because then you have a lot of working force in order to forage for honey and just produce honey. But too much brood in a set volume in a tree cavity is going to waste resources, and it might cause the colony, of course, to collapse. So the amount of worker bees or working force needs to be adapted to the housing, right? So it doesn't make any sense to the bees that we breed on them that they are eagerly, going after just a huge brood field, which we are doing in beekeeping. So we want breed bees that are creating tremendous amounts of brood. And when it comes to varroa mites, the varroa mite is a brood parasite. So if you have tremendous amounts of brood, of course you have a tremendous amount of varroa mites as well. So too many bees will trigger swarms, of course, so that's natural. And if not, because we are breeding on the bees not to swarm, negative effects will kick in. Of course, the waste of energy, disturbances of the processes. So you have too many bees in the housing, so they are hindering each other, because many of them, they don't have anything to do, right? And they're just hanging loose. And so they are getting in the way of the other bees that are working. And of course, this is not effective. And eventually it's being punished by natural selection at the end. So then you have other behaviors like grooming, washboarding, or propolizing, which we were talking about in the last meeting. It doesn't make any sense if there is no storage. So if a new swarm gets into a new cavity and there is no storage, then they are in danger of starving to death when the weather changes. So the first thing that a colony does when it really occupies a new home is building combs and forage in order to get storage security. And when they get storage security, and the brood field that they set up is being pushed down in the cavity by the intake, then of course you will see grooming, you will see washboarding, you will see the propolizing processes. And if we breed on the bees to groom each other of the mites, we are not inventing that genetic information because it's already there. What we do is we breed away the natural triggers. So we breed on the bees. Okay, we see, okay, that colony is able to kill varroa mites by effective grooming. So we will try to breed from those bees, and we will try to breed away the natural trigger that this behavior is only being shown when they have storage security. And what then comes out is a bee that might be more fitting to our personal needs, but doesn't make any sense to a colony to occupy a new cavity and start grooming, because then maybe they of course they have a limited working capacity, each and every bee in the colony, and it depends on the composition of the behavior. So if they are, you know, in the majority of the bees starts to groom each other instead of, you know, foraging nectar and getting the intake, and bad weather comes along, then they will starve to death. So it doesn't make any sense to the bees. It probably makes sense to, yeah, to the beekeepers if they are neglecting that breeding is almost, is not only almost, but it's always diminishing the ability of the bees to survive independently in nature, because we are more and more changing the composition of the behaviors, which doesn't make any sense to the bees themselves. Yeah, so if you have late swarms, for instance, I was highly criticized when I have late swarms in August or something, and I didn't feed them. So, but a late swarm is, in our location where I live, is a genetic, you know, failure, because of course there is not enough nutrition to feed that swarm, so it's going to die. That's natural selection, and as a preservationist, you don't interfere with the natural selection processes, right? So what I do is, when I have a late swarm, I have these empty tree cavities, the shifer trees that are hanging around my house, and of course they can occupy one of those, but I wouldn't feed them. I wouldn't try to make them survive artificially based on my help, right? And because a late swarm is, yeah, it's probably genetic corrosion. It's a behavior that shouldn't be there, and of course the offspring has a different set of genetics, so it's going to try any behavior, and then natural selection needs to wipe out the behaviors that doesn't make any sense. And if you interfere with this, you will create a problem, right? So I often talk to beekeepers and they say, cool, look at these bees, they are absolutely lazy, they are not producing any honey, so you can, they even don't talk about living creatures. They say it's genetically unworthy material. So you got to kill the queen and put another one in, which will create more productive offspring. But then if you take a close look what the bees are doing in these colonies, these are mainly bees that are focusing on the hygienic behaviors, or on different hygienic behaviors, despite the fact that they are sitting in the box. So they neglect the wish of the beekeeper to fill empty boxes, and they're keeping care of themselves. So there ain't a bee that is doing nothing in a bee colony. They're always doing something, and it's only the question, what are they doing collectively, and which behavior is being played out. And the behaviors that are being played out that are doing good to themselves are the ones that the beekeeper doesn't like, because then they don't focus on foraging and creating honey, right? So they are considered lazy bees, and then normally the queens are being killed. And I've seen colonies that were really good in grooming, so that they were going after the varroa mites, and they're cleaning each other off the mites of the bodies. And it took a lot of time, because you had, you know, on one comb you had hundreds of pairs of cleaning each other off the mites. So they were highly effective on survivability on their own, but they were, of course, immediately killed by the bee. So the queen would have been killed by a beekeeper who is looking for production, right? Because this is not the behavior that is doing anything which the beekeeper wants. And let's take a look at some natural behaviors then. And I will give you a few comments on that. So this is an old straw scabbed, and the really interesting thing is that, look at the bees, they are going back and forth and they are wiping off the surface. This is washboarding. And so the beekeepers, they were always thinking of, oh, what are the bees doing here? It doesn't make any sense, and that's right. It doesn't make any sense if you look at the entrance. But it's more effective when you look at the outside. This bee is bringing out a wax moth larvae, so it's doing hygienic behavior, and it has killed the larvae before. So, and the interesting thing is that these bees are not flying; they are not doing any foraging. Yeah, right. So look at them; they are not foraging at all. They are just, doing that, doing washboarding, bringing out like parasites, doing rumen, propolis the inner walls, and so on and so forth. But they are not foraging. And so there was a box next to it, and that was right in front of my bed, right? So I could study the bees by lying in bed, which was really convenient. And yeah, so the box was foraging all the time, even at 5:30 in the morning, even though it was raining. The box was flying and foraging. And the answer why they're doing it, it's compensatory behavior, right? So they are foraging because they lose that amount of energy, which you can see with the thermal camera, and bees will adapt to it. So the bees in this gap, they didn't care about foraging because they had enough storage and they had not that heat loss every day. And so they could, convert the amount of working capacity that the box hive is using to compensate the energy loss. They could use that time for hygienic behavior, which they did. So the behavior almost instantly changes if you set a bee colony into natural conditions. I think that's the same thing with any animal, but in beekeeping, you would be surprised that beekeepers really think that a box is, appropriate habitat to bees. So if you look into a tree cavity simulation like that, see the humidity at the walls. There is a lot of humidity, and of course, because of the fact that this is a new cavity, the humidity would cause mold. And look at the ground, look at all these living organisms crawling around there, a lot of mites and so on and so forth. That's the microfauna, which is of course in beekeeping being wiped out, and with a broom really, so keep it clean. And this is another problem that we have that I will refer to right now. You see, that's a natural cavity, and it's a wild living colony in another city next, near to my house. And that's the organic material that we find in the ground. And it's alive, man. It's the microfauna. And then you have, of course, these bees that are weak or that are in the dying process, like the one that you see in the left corner now. And you see it has crippled wings, so that's a deformed wing virus from the varroa mites. So that bee has been genetically altered by the fact that it was bitten by varroa mites, and it has been infected by a virus that is then changing the development of the wings. It's not able to survive, and it's then, of course, falling down. And the wax moth larvae here, they are all waiting for that bee in order to stop crawling, and then they are being eaten alive. There's another interesting factor about the microfauna is, of course, the book scorpions, which are bioagents. So you have hundreds of species living in that organic material. You can say that a bee colony in nature is the mother of a whole mini ecosystem, because the climatic conditions that they are producing in the cavity plus the organic material that they are producing, which is falling down like wax, pollen rests, sugar rests, and so on and so forth, and bee bodies, and so it's all consumed by that microfauna. So the microfauna is going to adjust to adapt to the bee colony, and then you have hundreds of species living in a mini ecosystem within the tree cavity, which has never been shown in any movie as far as I know. And another interesting factor about that ecosystem is that I'm doing climatic scientific research on these cavities, or I have been doing that for years now. And there was one in front of my house, and I was collecting the climatic data, and I saw like, okay, the bees had survived the wintertime because the sensors showed me always 20+ degrees and Celsius, within the winter time where we had -degrees outside. And I was really surprised when I saw in the springtime that the colony was not there, but the sensor still showed me 20 degrees plus. And then I took a closer look what was going on there. And the fact was that the sensors were lying in the compost, in this microfauna, which is like, which is producing temperature. It's like a floor radiation, and it helps the bees to stabilize the inner climate of the cavities in order to survive the wintertime. So it's literally saving them energy because it's producing heat. And these factors have never been shown in any movie or in any book, has never been described in any book. And you will find this only if you, by incident, that wasn't planned, so I just stumbled across that. So there's another factor that, of course, that microfauna consists out of species that would like to feed on the combs or even the brood, like wax moth. And the wax moth, like here, see, they are being chased by the bees. So you have a special forces by the honeybees, and their job is just to make sure that all the other creatures that are trying 24/7 trying to lay their eggs on the combs are being chased away. And when it comes to beekeeping, again, as a comparison, the bees, they don't need to have that behavior or have to show that behavior anymore, because of the fact that the bee colony, the bee colonies are living in boxes, and they very often they have a mesh bottom, so that all the organic material will fall out into a drawer, and the beekeeper will just broom it off, so keep it clean. So, and what happens then is that these bees, even though they don't have the behavior of the awareness of 24/7 to chase away natural enemies, are going to survive in a box, which they wouldn't in natural conditions in a tree cavity, because then they would be eaten alive, right? And this is one example of, by keeping bees in boxes or in an artificial environment, that just keeping them in boxes will cause genetic corrosion to them, because bees are going to survive that wouldn't survive in natural conditions, and then you rebreed from these bees. And so the amount or the level of genetic corrosion is going to increase just by the fact that you're keeping bees in unnatural conditions. So natural selection can only happen in natural conditions. Everything else is man-made breeding, and is not doing any good to the species itself from the perspective of the species, of course. Yeah, so you have that special forces, which you can only see when you do such a research on tree cavities. Here, the condensation again at the inner walls, which would automatically cause mold spreading. And there you see that the bees are chaining up, right? This is the three-dimensional web of bees, a network of bees. And they are all chaining up and create that three-dimensional web, which is then highly reactive, which is like, it's like these are all bounces, if you want. So they check who is going to get up to the combs, and we'll take a look at that behavior in a few moments again. That behavior, which you see now, is washboarding at the inner walls where we had all the condensation a few hours before. And so the bees are going back and forth and wiping the surface dry, and then you have the ventilation bees sitting in between of them and doing the ventilation. So ventilate the humidity, the water molecules into the atmosphere, and there's the three-dimensional web. So what is again interesting on that washboarding behavior, we'll go back a little bit and look at it, is that these bees are being fed by gasoline bees. So bees from the combs will go up and down and collect some energy in form of nectar or honey, and then they will go to the bees who are doing that job, like ventilation job, and then they will feed them tongue to tongue, so that the bees who are doing washboarding for hours and hours wouldn't have to leave their position until the job is being done. They are being refueled in the working process, right? So another thing is, yeah, that's the three-dimensional web. And now look at the bees flying into it. You can see that the bees are reacting to the incoming bees. So it's going to create a movement, a little bit shaky. So you see that there's a wave going through the bees when bees are flying in. So foraging bees that come back home, they would have to fly through these channels through that three-dimensional web of bees. And if they are then, disclosed as an enemy, then you will have a wave going through the whole network of bees, and the enemy is going to be attacked within a second. You wouldn't see that behavior at all in a frame hive, of course, because that three-dimensional web cannot be created by the bees, which you can see in that picture. So they are trying to cling onto each other and create the three-dimensional web, but they can't because you have these frames. And of course, you have a very large entrance hole, which is like 40 centimeters long and 2 centimeters wide. You have a surface of 80 square centimeters as an entrance. If you compare that to a natural entrance hole, which has not even 30 square centimeters of surface, you have a lot of more heat loss by creating a gap like that into a cavity. And of course, it's very hard to defend because it's so wide. It's like if you want to protect your house and you're standing in your front door, that's fine. But if the whole side of the house is open, that's a much harder job to defend. So the natural behaviors of bees are being hindered to play out in that with these frames, and their communication, of course, is dissected onto like the number of frames that you have here. So which is an animal rights violation when it comes to the 5 animal freedoms, right? Because they have a right to play out their natural behavior, which they can't in a box like that. Okay. So a lot of side effects that you see here, they can be attacked very well by wasps or hornets, and they cannot communicate with each other. They are not effective in their defense, and of course the entrance is way too big to defend. Okay, so that is another thing that we were talking about. That's the ventilation streets. So at the later daytime, you will see that the bees will come out, and then like 10,000 bees will sit on the cavity, and they are doing nothing. They are just hanging loose. They are grooming of each other's mite. They are sleeping. So you have various behaviors. And I was like, okay, I was in a little bit in in trouble, because I thought there's a problem with the oxygen or something. So I opened some extra holes and I was doing some research on these structures. And then I could find out by going into it with an endoscope that the reason why they're doing it is they need to create these air channels that we were talking about. So you see all these bees are ventilating, and nectar has a huge amount of humidity, so they need to dry it. And then you have like radiation bees that are sitting next in the combs of the nectar and heating them up. Then you have the ventilation bees that will kind of ventilate the humidity from the combs down to the entrance hole. And there you see they are creating these ventilation streets. They are lining all up perfectly and ventilating the humidity from the combs, which you can't see because they are at the top of the of the cavity. So they are ventilating the humidity down. Whereas in the daytime, you only see the huge three-dimensional web. There is no vision or no channel to see the combs or the storage. In the evening time, they will create these airstreams or these airstream channels. And as well, there are the gasoline bees who are then feeding these bees, doing the job, right? So you have the bees that are running around here, and they are checking whether one of these bees needs to have some nectar or some honey, and then they will kind of feed it tongue to tongue so that they can effectively doing that job. And in order to get these channels, like 10,000 bees need to go out, and they do. So, and we don't know how they're doing it. We don't know who's going to give the signal and how the signal looks like, that they are all like, okay, we have to leave the house because they are now, processing the nectar to honey, but they do. And this is another example. If you have round shaped entrance holes, they are much better to defend. What you see here is the three-dimensional web of bees, which is going down into that cavity here. And yeah, let's take a look. So, and it can be clutched. So they can clutch the entrance hole when it's getting too cold or when there is a defense situation. And so they can very much, operate with that entrance hole, which they cannot do at all with a gap, right? So, which is interesting. There's the other three-dimensional web. That's a natural cavity, of course. And you see, these bees are a bit suspicious what I'm doing here, while I'm looking into their house. And yeah, of course, you have to be really careful, because if you disturb them, there's one signal and you'll be attacked like from all the bees together, which is, in beekeeping, it's very unlikely, because they might be a single bee attacking you, but the others, they don't really listen, or they can't hear it. Maybe you have two or three sometimes, but that's very seldom. And in tree cavities, that's a totally different story. So if you disturb them, they will give you a warning, like with a sound that they create. If they smell my breath, for instance, you will hear them like whir. So they will create that sound with their wings. So the wave of information is going through the combs, or through the whole colony, like all the neurons are clinging onto each other, and the information is in the colony. Then if you do it one more time, you'll be forced to leave, right? So you really have to be absolutely careful by doing scientific research on wild colonies, because of the fact that they are undisturbed and going after the natural behavior. So this is another one. At the end of the summer, the drones are not being let. They wouldn't let the drones in, because drones can be reproduced by the queen anytime. If the queen wants to have drones, she's going to lay eggs that are not be inseminated. So that's, in Germany you call it Parthenogenese. I don't know that word in English, but it's like, an egg that is not being, confronted, that is not being inseminated, and then a drone is going to grow out of it. So drones can be reproduced anytime. And of course, of the fact that when the summer is going to change, and or when it's approaching the winter time and the resources are getting low, then they don't need any more bees to feed on the storage. So that's why they are kicking the drones out. And here they are not really collectively carrying them out, but they are just clutching the entrance hole so that all the drones cannot really get into. And this is how easy it is if they have like an entrance hole which is round shaped, to control who is gonna come in or who isn't. So all these poor guys are bound to die then. So if you look at the chill bees, as I call them, so at the end of the day, you will see bees just hanging loose. You have some of these bees are sleeping, like this one here. But this bee, which is shaking here, it's like there's something itchy, right? And it's shaking its body, and by doing that, it's giving the others a signal to please groom me, right? There is something which I cannot get off, and please do it for me. And that's grooming behavior. But in order to show that grooming behavior, they don't have to be placed in an emergency situation, right? So if they are like in an emergency situation where they have to forage because there is no storage security, then they would neglect that behavior. It only appears when the hierarchy is right, when they have storage security. Or in other words, if you're starving to death, Keegan, you wouldn't care about your nails or your look or your hair. You would go out, find something to eat or feed on, and after that, you would care for yourself. And that's the same with the bees. It makes perfectly sense. So the bee who wants to be groomed is giving that signal by shaking its body. Here in the corner at the left, you will see another pair grooming each other. And right in the center, there is a pair that is grooming. And so this is how it goes, right? So the bees, they will then give that signal, they will groom each other off the mites. And of course, the mites will be bitten off. There are some pictures in the book where you can see that the mite bodies are being kind of bitten off. And because of the fact that the mite is not having any muscles, it's like a hydraulic system. So if there's a little puncture in the mite's body, it's going to die. Literally, it needs only one little hole in the body of the mite in order to get dysfunctional and die. And this is what they do. Now you see two pairs of grooming bees next to each other. And so that colony was a lazy colony when it comes to beekeeping perspectives, right? Because it didn't carry any honey that was harvestable. Nothing that you could get out of the bees, but they were really good in caring for themselves. Okay, this is just giving you a little bit of insight of the natural behaviors of bees playing out in natural conditions. And very important is that natural development and behavior can only happen in natural conditions, okay? Everything else is compensatory behavior, and it's an emergency behavior. It's just an adaptation to any emergency situation that we place on the bees. And so there is no scientific research on the natural behavior of bees in boxes. It's gossip. It's as if you would do scientific research on the natural behavior of elephants in the zoo, or even worse, on pigs in an intensive agriculture situation, right? Important is that the behaviors and the composition of behaviors that are allowing survival in certain locations for honeybees are mainly unknown to this day. So beekeepers, they don't know what washboarding is all about. They usually don't know when bees start grooming, or if they can do it and that it needs to be triggered. They don't know all these things because they only know how to manipulate the bees to get the most out of it. And they don't know anything about the natural behaviors playing out in natural conditions because they never see this, right? They have the bees in the boxes and they can't think out of the box because all the problems are always there when they open the box. And so they think that's reality, which is not. So a bee colony is like a fine-tuned clockwork, which is all based on the genetics and the diversity of the facets of genes that has been passed onto the queen by 20 drones, right, in the mating process. So when it comes to that, the level of brood must be right and adapted. If there is too much brood, the bee colony will fail in natural conditions. If there is too less brood, then of course as well. So there is an interesting example of it, the black honeybee, which is, or the dark honeybee, which is the original bee in in Germany, or in our location here, in our climatic location, it adapts its brood mass to the nectar availability. And so why does it do this? Because the bees who didn't do this were wiped out by natural selection, right? So even today, where we already have interfered in the last decades with the breeding or with natural selection, the bees are showing that behavior. So if the amount of nectar in nature is getting low, they will diminish the amount of brood. When it comes to man-made breeding, if you look at the buckfast bees, for example, another name for another breeding of bees, then the goal of breeding is to create as much brood as possible, no matter what. So it doesn't make any sense to the bees, as you can imagine. The level of intake, of course, must be right. So if you have too much intake and too less space for the brood field, the colony is going to fail. If you have too little intake, then of course the colony will starve to death as well. So the triggers of different behaviors must be there genetically, and of course you would have to have the right composition all the time of when the behavior is not only the behavior being in the genes, it's when it is being played out. So the triggers are important, and then it's important that the amount of, let's say, washboarding or grooming is right, the intensity is right. So it's very, they are sub layers of the behaviors that need to be placed out, need to be played out. And I did some scientific research on 100 colonies in a bee apiary, and I was doing research on grooming. And what was interesting is that I could tell that they were like, these are all varroa mites, and there were like 3 colonies who were showing that effective grooming behavior. And these are some of the victims of these colonies. And you could tell that these mites have all been killed by bees. So the legs are being kind of cut off, or the body is being bitten in. And so I gave the beekeeper the numbers of the hives because I didn't know where they were standing or which hives they were. And he said, what's interesting? All these hives, are untreated. So he had these colonies in small boxes in order to motivate them to swarm, in order to reinforce the apiary. So they were undisturbed. They could just go and follow their biology. And all the others, the 97 other colonies, didn't show that behavior. So, and this is a strong message, right? This is how we came to the conclusion that there's a hierarchy of behavior, because we could then kind of place an empty box on top and see that the grooming behavior shifted. So it was then reduced to almost nothing, and the foraging process began as well. So bees are always adapting to the environment, which is important to know, because in beekeeping we are always kind of interfering with the outer, with the other, with literally anything, with the volumes, with the comp building, with literally anything. So we are altering the behavior, which would be normal or which would be natural. It's not that the bees couldn't cope with natural conditions, it's more that the bees cannot cope with the conditions in modern beekeeping. So propolization, there's another research paper. It's called Seasonal Benefits of Propolis, which I've forwarded to you. And it points out that the bees who are living in a propolized cavity or box are being much more healthy. They have much less pathogens on their bodies, in their bodies. Their lifespan is longer, and so on and so forth. So propolis is kind of the autoimmune system of the bees. And of course, if bees are not able to propolize, or if they have lost the information to propolize the inner walls, then they would fail in nature. In a bee apiary in a box, they seldomly propolize the inner walls, so it's not a selection factor anymore. This is another point where where bees who are not propolizing much are going to survive in an apiary, but they would fail in nature. And on top, there is a breeding goal. So the German, Deutsche Imkerbund, the German Beekeeping Association, is having breeding criteria, and one of these criteria is that they want to have bees that are propolizing less because it's so sticky on the fingers, so it's a bit inconvenient, so they are trying to breed less propolization on the bees. So it's another selection factor that we breed on the bees, and it doesn't do anything. It doesn't make any sense to the bee colonies, of course. The intake and condensation triggers washboarding. We have talked about that. So that's like dozens of thousands of hours a day they are doing washboarding, as you can see in this picture. So you have thousands of bees doing that behavior for like 5 to 8 hours. And if you calculate these labor time together, then you have like dozens of thousands of bee labor hours that they are, that they are doing that job. And if they are spending that much time on such a behavior, then you know that it needs to be very important. But it has been absolutely neglected in beekeeping, and so beekeepers normally have a question mark in their face. What they are doing there, they don't know, and so they don't really care. It's not in the breeding, catalog that bees need to have that hygienic behavior in order to kind of be good bees. Okay, what do we know? The comp building must be correct and sensible. It's another selectional factor. So the first thing that we had was when we did the rewilding projects in Germany, we had 75% of the bees that we set free in tree hollows were unable to build the combs from the top to the bottom. But they started like at the bottom and they tried to reach the top, and many of them had an empty space above their head at the top of a cavity, and so they lost their radiation system, they lost their heat system, and they failed, they died. And of course, in a bee box, in a beehive, they would have survived because they get wax sheets. It's like draw after numbers, right? So what children normally do, they have numbers and they draw a picture from 1 to 2 to 3. So it's like drawing at numbers for bees to build combs on wax sheets, which are imprinted with the profile. And bee colonies who are unable to build their combs without any structures would fail in nature. It's a selection factor, but they don't fail in a box as well. So that's another point of genetic corrosion by keeping bees in boxes and breeding from these these colonies every year that are surviving in the boxes because you don't have the selection factors which are in nature. This one, the picture that you see here is very astonishing because it shows a cavity that has the entrance hole at the upside of the cavity. So they would lose a lot of heat because of the fact that warm air always, drives up. What they did is they built a comb which is blocking the entrance hole, and then they made a small hole into that comb, and they propolized the whole comb. That's propolis, what you see there, and the shiny brownish, structure here. That's all propolis. So you have a lot of condensation, and you have water, you have organic material, and this would cause mold, of course. And so they propolized it thoroughly in order to prevent mold from spreading, and they made a small entrance hole so that they could block the airstream 100%, and they had a very minor loss of heat. So that was how they can adapt to a situation like that if they have the right genes. In beekeeping, of course, doesn't count at all. So this is one example of a comb building failure. If they start building the combs here at the brackets, for example, and not at the top and going down, so they would fail to meet the top, and they will lose their radiation system, and then they will starve to death because they have much more energy that is being needed to survive the winter time, and normally the storage doesn't keep up for it. So yeah, just an example. Of course, you have the door jobs, so the defense situations here, which we have talked about, and which they cannot do in the boxes, or they cannot really defend themselves. They cannot communicate. They have that open gap, and so that's totally different. And they need to be able, with a three-dimensional defense web that they are creating, they are doing three things. They are stabilizing the climatic conditions, because all the bee bodies that you see here in that three-dimensional web are heated up like our body is. So you have a clutch of warm bee bodies, which is then stabilizing the climatic conditions where the brood is at the top of the cavity. It is ensuring unhindered communication, and it's of course a defense against all intruders. So anything that needs, or that wants to get to the storage, or that wants to get to the brood, needs to get through that three-dimensional web, and you can be 100% sure that it's not going to happen, because they will unitedly attack the intruder, which they don't do in boxes because their communication is destroyed. So hygienic behaviors such as controlling the microfauna, we have seen that with the wax moth and chasing the wax moth. And of course, I've seen bees who are using the wax moth. So when they have an old comb, they were allowing the wax moth to dismantle that old comb, and after that they killed the wax moth and carried them out. So sometimes they're using them as a part of their structure process, which is astonishing. These collective intelligence, the ventilation streets that we were seeing in the movie as well. So where thousands of bees are involved, and the supply bees, and the inner web that we have here on the right side, and the chilling bees outside. So it all needs to work together as a fine-tuned clockwork. And I always refer to Barry Wendell. He said, we cannot know what we are doing until we know what nature would be doing if we're doing nothing. This is exactly what I did. This is why I built these tree hollows, where I thought, okay, I will give them back the natural conditions that they had lost due to intensive deforestation, and then I will just watch over the natural processes afterwards and learn from the bees. And of course, I'm doing research on wild living colonies in natural cavities as well, but they are seldom. Now, when we look at breeding, the picture is turned, I'm sorry, but if you look at man-made breeding and selection, that's totally different. Whereas, nature is breeding for survivability. Man-made breeding is, focused on the desires that we have on bees, right? So, what are the breeding, criteria that beekeepers have? Bees shall not defend themselves against the beekeeper, of course, but they shall defend themselves against all other intruders, right? Which is ironic. Bees shall sit on the combs when the nest is being dismantled. It's called Wabenstetigkeit in Germany. That means if you just dismantle the whole colony, they shouldn't fly around your head. They should, sit still on the combs. And if they don't, they will be degraded in the breeding criteria. They have a kind of report for every colony, and if they are unstable, not sitting on the combs when the beekeeper is dismantling the whole nest, then they will kill the queen and set in another queen, because it's inconvenient for the beekeeper to cope with all the bees flying around his head. Of course, the bees shall quickly develop in the springtime and create much brood as much as possible, even though they neglect all other different, all other vital behaviors that would be desperately needed to survive independently. That doesn't count at all, because beekeepers don't know anything about their natural behaviors, and they are only keeping, caring about focusing the working capacity of the bees in order to get honey out. Bees shall not propolize too much. We have talked about that, so they would lose their outer immune system, and the results can be seen in that research paper, Seasonal Benefits of Propolis. Yeah, bees shall be eager for intake. Of course, we achieve that due to a fake emergency situation where we put empty boxes on top, and the bees never get the storage security when the storage is, pushing down the brood field for the intake, and which would then naturally trigger the behaviors like wash spotting and grooming and propolizing and so on and so forth. And bees shall be resistant against illnesses, which is another irony, because we are breeding on them not to propolize too much, and we don't roughen the surface of the hives in order that they would propolize the inner surface, and we don't really care about their outer immune system, but we feel like in beekeeping, okay, we want to breed on them that they are resistant against illnesses, which is gossip. Bees shall show varroa-sensitive hygienic behavior. So there are some breeders here in Germany who are trying to breed bees who are kind of grooming each other all the time, which is ironic, because if they groom each other, they cannot forage on nectar, and if they are grooming too much, then they are considered to be lazy, and the queen is being killed. And the beekeepers don't know that there is a hierarchy of behavior, and that that this behavior has only been shown in a certain situation. And then they have now a kind of needle board, which has needles where the combs are, and then they stick it into the brood field, killing all the larvae with the needles through the body. And then they look the other day whether the dead bodies have been pulled out by the colony, and if they are not being pulled out sufficiently, then they will kill the queen, because they want to achieve that the bees are able to kind of smell the varroa mites through the cells, and then kind of get the larvae out, which is infected. Some bees can do this, and they're trying to breed that behavior on the bees by that method, which is absolutely cruel. And they don't even know that every behavior that we breed on the bees is like, trying to fix a Swiss clockwork with a screwdriver, because we're interfering with the whole composition of behavior, and we are doing highly unjust to the species itself by interfering and trying to make it better. So what is the goal of breeding and selection? Of course, it has the goal to subdue the bees' natural behavior to our demands. So, and we don't have only breeding which is regarding the behavior, but we have breeding regarding the look as well. So we select for the color, we select for the hair length, there's no joke, and we select for the cubital index. The cubital index is, as you can see on the wing here, is that fine line in the wing. If there is a genetic line of bees which is not showing that cubital index, the queen is being killed by the breeders, because it's not meeting the aesthetic demands of the breeders, right? It's like breeding dogs, or, so it's horrific, because it's not about supporting the bees. It has nothing to do with preservation or anything. It's just horrific. And now, if you compare the man-made breeding criteria to the adapted bees in the Amazon forest, who were a bit smaller, who have a smaller diameter of the thorax and head, who have a rounder wing shape, and who are all resistant towards illnesses and varroa mites, it becomes clear that all the bees in the Anod forest would have been killed by the breeders just because of their look. Yeah, and there you can see how much we are kind of interfering with the natural, or with evolution, and we don't even know what we are doing here. Yeah, we're trying to create bees that are adapted to our needs, and at the same time we are or the beekeepers are advertising that what they do, beekeeping, is preservation or species protection. And if you really take a look what they are doing, then that's the opposite is the case, right? So as long as the main part of the genetic pool is lying in nature's hands, breeding had no impact. So breeding, breeding has an impact since the ocean has been drained, if you compare it to the fishing industry. And so today the majority of the genetic pool of honeybees lies in human hands. And this of course has dramatic effects. If we breed the bees, if we keep them in unnatural conditions, we are causing more and more genetic corrosion every year, just by keeping them in boxes, or even actively by breeding and trying to subdue the bees to our personal needs. Beekeeping did not react to this fact until today, but it is, as I said, advertising, or just selling itself as being preservationist or species protectionist. There was a project which shows how lost we are, how we are unable to see the leaves by the trees, the trees by the leaves. It's called Fort Knox in Poland, and it's a unity of beekeepers who all said to each other, we are not treating varroa mites anymore. And of course then they have high losses, or the highest losses possible, and many lose all the bees. And of course some of the bees are then able to survive, because bees are always kind of able to adapt to new situations. And then you have some colonies who are able to adapt to the selection of factors and boxes, and then they would breed from these bees, right? And what they want to do is they want to make the bees better for beekeeping, so that they don't have to treat the bees anymore against varroa mites. And the beekeepers who are then having survivors will chop these colonies into pieces, and then just sell off small mini swarms to the other beekeepers, or they will give it to the other beekeepers, so that they can kind of begin from that they don't have to start over again. They can begin with these survivors of the boxes and varroa mites to reestablish their apiary system, or their apiary. And this is an enforced man-made breeding to artificial selection of factors living in a box, or to an artificial system which is only set up to serve human demands of production and exploitation. And the Fort Knox project was highly glorified in the beekeeping society as as outstanding, as the solution to the problems, and so on and so forth, which is absolutely horrific if it comes to when you look at the bees and their natural behavior in cavities. Until today, all necessary behaviors and the compositions that would allow survival in a certain location remain unknown. Okay, that's easy. And of course, the working capacity of a colony is limited. If they groom each other, they cannot forage, and so on and so forth. So every behavior that we breed on the bees will be paid with the change of the whole composition, and sometimes even eliminate abilities of vital importance. This is almost always the case when we do one drone inseminations on queens. So in order to have bees that are only serving our rudimentary behavior or needs, our rudimentary needs that are kind of based on very few behaviors, like much honey, calmness, not stinging, and that's all what we are looking for. And beekeepers think that this is all. Yeah, all human criteria that we breed or enforce on the bees are diminishing their independent surviving abilities, of course. And who gives us the right to do this? And I don't think no one has the right to do that. So it's just what we do in breeding. Yeah. And yeah, that's it for today. Oh, this is what needs to be said to breeding and selection. And yeah, if you have any questions at the end, just raise the questions or just give me an appointment and I'll come online. At the end, I will just a few thoughts about bee races, because you were asking me that as well. What about the bees who were not in certain locations until a certain point, and then we introduced them to the United States or to Australia, and now they are there, and shouldn't we kill them all, and so on and so. It's not going to happen, right? And even in Germany, we have like a racial discussion, I call it. Like, the bees in the forest that are surviving there, that I'm doing my research on, they are only man-made, right? So some beekeepers argue that they are bred bees, and so they are artificial creatures, and they shouldn't be there, and they don't have a right to live there. And it's if there is a colony who has the right to live there, then it's only the black bee, because this one has be the original bee in our part of the world. But I think it's a rather racial discussion. It shows how tight the focus is that beekeepers are looking at the whole thing. Because if I look at the bees in the forest, then I see only a mixture. So there's no Reinzucht, as you call it. There's no genetic, there's not only one genetic of bees, it's all a mixture of all the bees together, even the beekeeping bees together. And nature does not care about color when it comes to the bees. It does not care about their size or their hair length or the cubital index. Nature only cares about the composition of behaviors that is needed to survive independently in a certain location. And if they can adapt as an organism in our forest today, and they are not black anymore like they were like 150 years ago, then these are the bees. It's like, in the Arnold forest, you could say, okay, we should save the 20 genetic lines that have died out in the Arnold forest due to man-made breeding and selection and treatment of varroa mites, because otherwise these precious genetic lines will die out. This is how nature works, right? Natural selection will only make the genetic lines survive who are adapted. So it's all in a permanent adaptational process. And these bees who are now feral here in Germany in the forest, they are the bees who show all the composition or show the right composition to survive independently. So to argue that there is a man-made breeding impact on the genetic pool and that's why they are not live-birthy is a racial discussion for me, because it's the organism that is fulfilling its part in the ecological system that we are part of. And when it comes to other countries where bees have been introduced, new species are always kind of, even in natural processes, species are being introduced by birds or by other features, by drifting on a piece of wood or to another country. And so if these changes are natural, then we consider them to be a part of the natural process. If they are man-made, we always consider them of being kind of bad, because of course sometimes they have a very negative impact on the environment where they are being introduced. But I would say from the perspective of nature, nature doesn't care about this, right? Life always finds a way, and there is always a part of adaptation. And so, you know, the ecosystems are all in a permanent change of adaptation and adjustment. And I would, you know, I wouldn't whine about spilled water. So you cannot kill all honeybee colonies in Australia. You cannot kill all honeybee colonies in the United States. That's over. We don't need to talk about that anymore. It's not an issue anymore. But we have to talk about their part in the environment. So they're part of the ecological systems that we are part of, and how much collateral damage we are now doing by extensively exploiting these bees and exaggerating the amount of nectar that is flowing through these hives. And yeah, so I would always refer to the example of the almond forest, where within a few years the bees have been changed. And then thinking back of, you know, trying to preserve the bees who have died out is like recreating the mammoth to me. It doesn't make any sense, right? So the whole genetic pool needs to be in a permanent process of adaptation. And this is what we see with the bees who are now feral or wild here, living in Germany or even in the United States. Yeah, that's it. And there's an optimum and pessimum curve, which is as well interesting, at least, because optimum is, you know, are all the criteria that are, you know, optimal for a certain species in a certain location. That's the ecological niche of every species, right? If they have the optimal surroundings. So, and when it comes to honeybees, it's like 35 liters of volume away from the ground in a forest, and so on and so forth. And if you change that, if you change these, you know, these features, then everything that you're changing is bringing the optimum curve closer to the pessimum curve, which will eventually lead in the colonies failing or dying. So if you put the bees in boxes, we will go a huge step from the optimum to the pessimum. If we then, you know, put them on frames, we will even get closer to the pessimum. And if you then use sugar water on them or enhance any volumes and so on and so forth, then we will kill the bees or bring them into conditions that are highly unlikely that bees are going to survive these situations. And so we are permanently keeping our bees in pessimum conditions nowadays, and treating the side effects and trying to, and that's the irony, we are trying to adapt the bees to the pessimum conditions because it's more convenient for us, instead of giving them back the natural conditions that they have evolved in. Okay, now that's it for today, or even for that presentation. I hope you liked it, and yeah, just give me some feedback if you have any questions. Come forward and tell me that, and I will then get into discussion with you. Okay, Keegan, bye-bye.